Welcome to Bad Station Works, and in this build series we are building this 800 kilo 400 horsepower old Swedish Mailtruck powered by a Volvo T5 engine in a mid-engine setup. And today we're going to do the first burnout. So welcome again. Before I could drive the car, I kind of had to fix the brakes. I'm not a very careful type, but like having brakes, even though for a small trip, yeah, that's important. So the rear brakes were quite okay, but the front ones, they were in terrible shape, at least cosmetically. When I took apart the calipers, I found that the actual important parts were in good shape. You can kind of see it a little bit here in the center of the shot. So I cleaned up the outside a little bit and rebuilt the calipers with some fresh seals and rubbers. We are putting back the actual piston in the single piston calipers. They were a little bit hard to press in. The other one went in very easily, and this one at one point just flooped in. Yeah, so a new seal around it. The most important part for this seal is the most important job for this seal is to keep out the dust. I didn't really see it well on the caliper side. Doesn't really matter because it can't really go anywhere. But anyway, we are cleaning what's it called? The ears, so to say, where the pistons move in and out. So they get new rubbers here, and it's not the main piston obviously, but the pistons that for the floating part of the caliper, they move in and out in this rubber, and they're quite stiff, so they're quite hard to get in. But yeah, this is the piston. And then the actual floating part goes in like this. You can see it really looks like a remnant from the Titanic or whatever. It's a little bit hard to get in because I tried to brush off most of the rust and all the rust cake, but it's good enough. I'll probably replace the calipers completely, but it's purely cosmetical. Like the brake pads and everything's fine. I even recycled the brake pads because they were like brand new. You can read all the lettering on the back side, and well, I can't see anywhere on the pad, so rough them up a little bit, and then that's it. Oh, and here this is cool. So I also had to make some brake lines, and I had been advised to buy one of these devices that you see on the screen now, and I'm really sad that I haven't listened to that advice before, because well, it literally takes less than a minute to make a brake line, and they always come out perfect, except for when I forget to put in like a brake nipple. But that's on me. That's not on the machine. But it's like 2 moves, like 1, and this is number 2, and that's it. Unclamp it, take it out, and then if you take a close look, it's focus, please. There we go. Nice double flare, works perfect. Haven't had any of them fail. Up next, bleeding the brakes. It was kind of easy on the rear axle because the bleed valves were good enough. You can see me. I had to put a little bit of effort in, but at least I could get them off. But on the front axle, they were so far gone. I still can't get them off. But the bleed nipples, I just got them in the mail, the new ones. They took a little bit longer to arrive than expected, so I'm going to replace them soon. But at least the rear brakes worked, and they still work. They work fine. So this was good enough for me to be able to drive in and out of the workshop. That's the only thing I did. I didn't drive on like the public roads. Just like drive to the beginning of my driveway, turn around, drive back, see like the vital signs of the car if everything's fine. And do a burnout, obviously. Don't need all the brakes to work for that. And then it was time. The first real drive of this car. life. So after this, it was time to get back to wiring because, well, waiting for stuff to come in the mail, wiring is always something you can do. So I chopped up this original S60 bracket that takes the what's it called, the rear car module, CRM, whatever. Well, that should be mounted in the rear of the car, and I found that while laying out the whole harness in the car, this was a very nice position in this like void next to the gearbox. So if I weld this to the frame with some extra mounts, it's quite a nice and clean place to put this this module. It's a little bit like a small computer and some fuses and relays for everything in the rear of the car. So fuel tank, well, that's now in front of the car, but originally it's in the rear of the car. Fuel tank and tail lights, etc. Talking about tail lights, with this in place and like the wiring roughly where it will be in the future, everything's going to be trimmed down to the bare minimum wires, etc., etc. But like the location shouldn't change much. So now it's time to wire up the tail lights. Not very necessary in this stage of the project, but it is a very nice, very visual thing to do. And well, yeah. So I got some Deutsch connectors for this, and in this time lapse you see me wire up the Strands. What's it called? Strands Siberia MO multi-option, whatever. Tail lights that have indicators, brake lights, normal tail lights, and reverse lights. Reverse lights don't work because I haven't wired up the reverse switch on the gearbox yet, but they are wired in and they should work. So I just mapped everything from the original tail lights to, well, not mapped, yeah, I wrote down all the pins and then just cut them and wired them up to the Strands lights. Left the wires a little bit long. I'd rather zip tie them away later than having wires that are a little bit too short, especially with the flip hood. Well, not flip shell, I should say. And it works, as you can see. Tail lights, blinkers, and when pressing the brakes, the brake lights also work. That's nice. And now that the tail lights are working, I'm jumping onto the front end of the car. I installed headlights already. The one in screen now is taped up for the scanning because, well, transparent stuff doesn't really scan well. But now it's time to install the separate indicators that are mounted underneath the headlight. So they are, if you mount them as they are originally, they are on a different plane. So like the front of the indicator has a different angle, so to say, than the headlight itself. And I thought that's not very nice. I'm not sure how it is with the original Joven. So the lights that I'm using are also from Strands, so they are aftermarket. But I decided to draw up a simple spacer that like just angles the thing and makes it look nice. So here you see me work in Fusion. And well, this section is going to take a little bit of time, so if you're not interested in 3D drawing, then please skip ahead because there is more video and a burnout in the end of this video. So please stick around. But for the guys that are interested, or girls that are interested in 3D stuff, well, this is me drawing up the indicator. So I imported the 3D scan with what's it called? Textures. And yeah, here I'm aligning it and searching, making a plane like to align everything to. So the mounting points where the headlight mounts to, that's the plane I want the indicator to also align with. So that's what I did here. Making a new sketch. It turns everything around 90 degrees. No idea why, but luckily there is this button on my space mouse that turns around view 90 degrees, which is nice. But let's start. And well, the reason I used this texture is that I could see the original mounting point, so I could like kind of use the same size, and also stay clear from this like ridge that's underneath the height difference thingy that's a little bit underneath the circle that I just drew up. So 75 mil, that's what I chose, about 3 inches, and then I measured off camera the 70.3, but I chose 4 because, well, PLA always shrinks a little bit when printing. But that's the outside diameter of the actual light that has to sit there, and it has a little bit of a lip. So I chose 2.5 mil. It's 2.3, but again, it shrinks a little bit, and I wanted to be a little bit deeper. So I made this little ring that the indicator sits in. Then I selected the circles that I drew up again to extend them backwards. This is only the inside, so I need to select both sides. Try to select the object, but that doesn't work with meshes. Here I select the outside ring again. So now I have a full ring, but it's now parallel. That's not really nice. So I give it a little bit of a taper, so it looks a little bit more deliberate. Needs to be a little bit deeper. So now it just goes through and through the mesh, the 3D scan. But cutting it to exactly fit to the fender, that's a little bit later. So first I have to finish the actual basic shape. That's what I'm doing here. So this looks nice. Nice shape, clears everything. Just have a look around, it looks good. Now I make a little tiny notch in the bottom of this shape because, well, the light that I'm using has this notch to align. So I want to make sure that when I print the other side of the car, it has the same notch on the same place, so the lights have the same orientation. So this works nice. Now the next thing is a throughput for the wire that comes from the thing. It doesn't need 20 mil, but again, I don't want to care too much about the actual orientation of the light unit. So roughly there in that corner, like at 9 o'clock, it should be. That's it. So now it has a hole. And the next thing I'm going to do is make it a hollow. So now you can see if I would press OK, it will cut away everything. But if I give it an offset of 5 mil, it creates a kind of like a hollow. I know there are special functions for this, but I want to use the taper on the outside and like a straight indentation, so to say, in the inside. So the walls get progressively thicker from beginning to the end just for strength, I guess. So here I'm going to create a shape, of a form, I should say. So this is a form, and that will mimic the scan. So now it's flat, and here I'm messing around a little bit because, well, it's still a little bit new for me. So I need to learn this still a little bit to get this muscle memory, so to say. But the thing is that you start to move around shapes or vertices, and Fusion then calculates the angles that you need to have between the parts. And this makes nice curved surfaces, and this surface you can use to cut solid objects. So the spacer that I designed is a solid object, and the mesh, the scan is a mesh, but you can't cut solids using a mesh, not as far as I know. I did a lot of Googling, but I can't find it. So the workaround is to make a shape, a form like this, which is also a B-wrap or a solid, so to say. And you can use that to cut the spacer that I made. So the thing that I'm trying to do here is to align it as closely as possible to the original shape. doesn't have to match like in like a thousandth of a millimeter, but it has to be as close as like possible in the given time. So this is a little bit finicky, but this is one of these things that you get better and better in if you just do it like often. But as soon as you kind of have the original shape, you start with as little as squares as possible, as little vertices as possible. And then when you have the basic shape, you can add more vertices and fine tune the shape that you made. So that's the thing that I learned already from watching a lot of YouTube videos about this: is start with as little shapes as possible, and then fine tune where needed. You can see the scan poking through in some places, but that's not very important in this case. If you want to have something that like literally lays flat, then it's important. But for this application, we just want to cut the solid, the spacer, the adapter thingy, as closely as possible to the body. So now I finished this shape. It's good enough. So now I can select the spacer that I made. I'm going to change the taper angle a little bit from 10 to 5 degrees because it was just outside of my shape, and I thought it was easier to just change the taper. So here I click split body, and the body to split is obviously the spacer thing, and then I use the form that I made to split it. Then you get two bodies, and if you just remove or make one invisible, then you get the other one that you need left over, and this has a perfect, nearly perfect cutout that like fits to the body perfectly. You'll see it later when I install it in the car next scene. But this won't just float on the car, so I need to make mounting points. I could have also just like glued it on the car, but I think that's a little bit hacky. So what I decided to do is make two ears, so to say, to use two 5mm bolts to bolt it to the car. So here I'm making the ears. Not very fancy CAD work. Has to be very precise. I could have used mirrors to make the top and bottom ones perfectly the same, but there's no reason to do that. It's just it's just this. It's not a very critical part. Accidentally made the holes for the thing way too big. So later I'll size them down to was it like 5 point something mil. So this is here I'm making the cutout. I wanted to start a little bit. Well, first I make the solid and then cut again for the actual clearance for the heads of the bolts. Well, that floating knob is not going to work, so let's delete that too with proper extrusion. Here I like reverted the change in the timeline. So yeah, here you can see the cut part. The ear is a little bit thin there, but it's just like a part that's just a few grams. But well, more is always better. I think my American viewers will agree with that. Yeah, this is turning out to be quite a long section on this Autocad stuff, but I think it's worth to show because like if I don't show this, it might appear that these parts just fall out of the sky and they just appear. But this is also part of the process of building a car like this. And now that like the most of the rough stuff, like the big like the frame building and engine stuff, it's done. Now we get to the part where we make these finer, so to say, the finer details, like these indicator spaces, etc. And well, they're an important part. So So save as mesh, finally. Saving as mesh means that I can save it as an STL file. An STL file is the thing that the slicer, the 3D printer software understands. That's that language. So here I import it, turn it around, and I see that like this is going to need a lot of supports, and more supports means more printing time. I thought about flipping it upside down, so face down. But that's not going to look nice, and well, the front needs to be the nice part. So this is going to the way I'm going to print it. So it needs a little bit of support. Luckily, the curvature is not that extreme. So here I switch from PETG to PLA to have the right color, black. This is all the printing stuff generated, the supports and everything. Looks good. So print. Send it to Daniel's printer. And after printing, it's finally time to install it on the car. And as you can see here, the fitment is perfect. So this is not like a number iteration, whatever. This is like the first iteration, the first print, and it fits perfectly. So threading the wires through the hole. I'm happy that I made it hollow, because I could use a hole that's already there in the body, so I didn't have to drill another hole in the body. Feeding the wire through, and turns out the fitment is just like a press fit. I'm going to glue it down, maybe not, probably not, because it's a perfect fit. This looks nice. I'm really happy with the fitment. Next step is printing a ring, a surround for the headlight, so everything ties together a little bit better. So I'm back at wiring. Still don't hate it. Still sane. Still not lost my sanity. As you saw in previous shots, I installed the rear tail lights, blah blah, everything works. The only thing that keeps being weird is that as soon, well, I disconnected the battery now, but as soon as I turn on the car, turn on the ignition, this light comes on, not that light. This is high beam, that's low beam, and that should be low beam. And if I flip the stalk on the steering wheel, nothing changes. So my guess was that something's wrong in the wiring. Well, the wiring is quite simple. So you have the handle, the lever, and there is some wires going to the junction box, the relay box. And that was an easy check, because the C6 plug on that thing was the only plug that didn't change. So in the whole system between between light stalk and the lights itself, the only thing that changed or was unplugged was this. And well, this I wired. And so I checked, well, I think I found it. I haven't checked it yet, so next shot will be either happy me or not. But so the wires, this is the relays, and the wires that go from the relay box to the this plug, this junction, which is 54.3, are blue and green. That's weird. I have blue and blue white. Oh yeah, blue white and blue, and green is not green. That's gray and blue. And the thing that I found is this side of the plug I didn't unplug is gray, not green. I think it's very confusing, by the way, but gray and blue are in the third row, which I labeled C, in C2 and 3. So this red and blue wire, this first one here, that's 1. So this is 2 and this is 3. But on this side it was kind of hard to see. And you can see I didn't count the first red and blue wire. So I put C3 and C4, I labeled it. See here, the white, the blue one and the white blue one, they are C3 and C4. It's kind of hard to see, but I have only 2 hands, and one is called holding the camera. So they shifted, since I miscounted, just miscounted, since this plug, it is labeled. So if you look closely, I don't know if the camera will focus on it, but if you look very closely, there are numbers. But it's really hard to see, especially with a little bit dim lighting inside the cabin here. Anyway, long story short, I think I just have to move this blue and blue-white wire up one hole, so the blue one goes in the empty spot there. That should be it. So let me move that and then see if we fixed it. Okay, I just hooked up the battery, which is also new, by the way, because the old one that's over there, it died, or at least didn't take enough charge anymore. Anyway, so let's turn on the ignition and see what happens. Yes, there we go. Low beam. And does the high beam work? No, that's the... No. Yep, high beam. Happy. Now I can start to hook up the headlights. Yes. High beam. Indicator. Well, I have to switch out the relay. It is ser bra ut. Jaha. So then something weird happened. So the car started to sputter and almost died as soon as I applied some power to the wheels. So I thought it was the alternator not being hooked up. But after putting a belt on that, well, it turns out that wasn't the case either, because it even dies now. But after checking some stuff, I thought it might be as simple as just too little fuel. I didn't put much fuel in it, so the fuel tank would still be liftable, like not too heavy. So here I put in a little bit more fuel, and then it happened. It works. Okay, dat is te bezien dus. So that's it for this video. In the next video, hopefully I'll be building a fuel tank and getting the coolant system ready to actually make a drive instead of doing like a 5-second burnout and then quickly turning the car off, because it will probably overheat without any coolant at all. So yeah, stick with me, subscribe and like. It always helps the algorithm. And well, oh yeah, check out the web shop. Soon there will be new designs on the web shop, and I'm working on them like right now. Well, not right now because now I'm recording, but when I'm done editing this video, then I'll be back at the designs. Anyway, long story short, thank you for watching. See you in the next one.